Yeah. So, okay, guys. So let's start. First, thank you for joining. Thank you for finding the time to hearing us today. We will talk about the AI in industrial operation and how companies actually automate manual processes with the custom software. If you are here at this webinar today, most likely you are in the production, in the manufacturing, in the renewable energy, in the other energy domains, and you're at the edge of the operational and the software fields. And you may be thinking about the AI adoption or AI transformation into your production processes. And we will talk about this today. Who is speaking? My name is Max. I'm a managing partner in Techstack. For the last 10 years, I've spent building software companies. Also had a lot of experience working with manufacturing projects in US, in the construction project and energies. My co-host today is Andrei Kurylenko. And Andrei, hi, is leading R&D in Techstack in AI in adoption and AI implementation processes across most of our projects. So he was the one who developed most of the project that we are going to talk about today. Making his dirty, he traveled on site, but yeah, he will talk about this later today. So quick agenda, what we will cover. First, we will dive into automation in US manufacturers in 2026. We will focus solely on US market today. Let's talk about the trend, about the market data, what's already built, what is in process. We will talk about real cases that we delivered in Techstack, working with the real customers at the real field projects, not any sand projects, not in the lab conditions, and in real industrial environments. And what is most important, why sometimes automation projects fails, and what makes them successful. And at the end of the session, we will have a Q&A session. We always try to make our webinars interactive, so please, in the chat section, you can drop any questions for us down the road, down the presentation. Maybe you will have some thoughts during some slides or some information, and you can just drop us the messages during that. At the end, we'll spend about 10 minutes with Andrew to answer them. And the whole webinar will take about 1 hour. We will try to make the last 10 minutes free to answer your question and make this interactive part. So we can start from here. And the first about the Techstack. So Techstack is the technology partner. We were 12 years developing software projects. We have 200 experts in-house. And everything that we will talk today is based on our own experience in the real projects. So we gained a lot of experience during these 12 years. We were one of the pioneers in AI adoption and implementation into automation processes. And that's why we are not AI optimists, but AI realists. And we will talk today why sometimes AI can make the processes faster, and sometimes it can bring more troubles for you, and what the homework you need to do before implementing AI into industry automation. Yeah. So let's run some numbers. So the biggest takeaway here is that 77% of US manufacturers already implemented AI to some extent, and 93% say automation is critical, but only 37% have it in place. And this is the gap that we are going to tackle today. The difference between this 92 and 37%, it's more than 50%. And this is where the automation will excel in the next 7 years due to our research. So unplanned downtime costing US about 50 billion annually. Only Fortune 500 companies lost 2.8 billion per year, which is about 11% of the revenue. So it's not the something new anymore. This the automation in industrial. It's the trend. So everyone will be there, and if you are here, maybe you right now you're thinking about your own production and seeing, and you want to make the first step, where to start, what's point in your production line bringing the most pain for you, and how you can resolve that. I hope the cases that we'll share today will help you to make this first step. So why the automation is accelerating right now? Here are the 6 industry trends, but the red line across the whole these trends is that the time to implement AI automation is right now. It's not because this is something new, this is the trendy theme. It's because the market pressure. It's because the competition. It's because actually right now the technology is already there. Maybe 3 years ago it's bring more pain implementing that, but right now it's ready. You just need to adapt this to your own business processes. So first point, it's labor shortage. 1.9 million jobs could be unfilled by 2033. The main driver here, actually, well, we are talking about US markets, it's reshoring. So some of the production is going back to US, and right now we have several clients who opening their factories in US from the scratch. They setting up all the processes from scratch in US. This take a lot of time, a huge investment, but the problem is, yes, that we will relocate the factories to US, but we cannot relocate workers, right? And we predict that by 2033, the shortage of the workers in this field may be very critical. So thinking about automation right now may resolve this problem later. The second trend, AI move to the edge. You don't need cloud to run the models. Everything can be on-prem right now. And this is very important if we are talking about manufacturing, if we're talking about defense sectors, that you need to have everything on-prem in-house to not leak your data. And right now, we are ready for this. Third, data cells breaking down. ERP, SCADA, MES connection are at the point that they can be connected into one view. First, predictive over reactive. We will talk about this at our cases today, but the main trend here, we need to cause problems at the earliest as possible stage in the production chain. So when you cause the problems at the beginning, it will save the lot of money at the end. Trend number 5, digital twins go mainstream. About 5 years ago, we created digital twins project, and it was like something new, something very trendy. Right now, it's already industry standards. It's 75% enterprise already using digital twins, and this percentage will just rise more. And of course, regulation drives traceability. Visibility of your data, it's not anymore the option, it's the part of the regulations, and you need to work on this right now. Here are the industry benchmarks. We will talk about 3 giant companies. It's Procter & Gamble, who deployed vision system and sensor across production line to replace manual sampling. Caterpillar real-time anti-monitoring system works across 1.6 million connected assets. This is the predicted maintenance facilities projects. And General Electric built digital twin platform to monitor and optimize grid performance across wind and solar assets. So what is the trend here? What is in common between these 3 corporations, these 3 giants? First, we can see that Procter & Gamble started with one production line, Caterpillar started with one type of assets, and General Electric started with optimize one grid performance. So the trend here is that you will take one problem, you will measure the predictable outcome from this project, you will measure success, and only that then you are scaling the solution. And we see here that those problems are resolved at the huge scale. And when it brings the most ROI for you, you're going to automate the next problem. At this place, I will pass my word to Andrew. We will talk about our real cases in Techstack, and I hope you will get a lot of insights from the real projects. Yeah, word to you, Andrew.
Thank you, Maxim. Hello, everyone. I will showcase some of our successful implemented projects. We'll talk a little bit about them and how we implemented them and what issues they actually solve. But let's begin with questions to ourselves. Everyone here heard about AI. Everyone heard that it works. It can automate something and improve something in processes. But the AI or all of the data science approaches in terms of production and plant level integration is a way different than what we used to see in our smartphone applications like ChatGPT, Code, etc. That you're just asking something to do and it does something magically or not. It depends. Yeah, let's dive deeper into our project itself. And our first case is computer vision quality control. The client was a global manufacturer of building materials with 80 plus factories across North America and Europe. They has high volume lines, production running continuously 24 hours a day, 7 days a week, well, as usual these days. At this scale and production speed, they estimated already with classical needs a lot of their processes, and most of their plants were running with really low amount of maintenance workers on site. And lines were running from the very beginning of production and up to packaging full automatic mode. And that was actually cool and impressive, but it has its own downside. They didn't have the proper quality control on those lines because people were not present on those lines. They could not see on what's happening and could not prevent those issues once they happening. So they as a result, they had a lot of reclamations and returns because some botched or defected packages were anyway shipped to clients. So our main goal was is to implement early detection of production defects, alerting about them, fixing them, and preventing them from happening. We visited plant. We talked with the workers. We saw the good products, bad products, and we collected a lot of data to just begin with and to start implementing. Then we began to work on the hardware ideas, and the solution ended up as being as a high-speed cameras placed all around the production line, looking right on production belt and checking everything that are going through it. And all of the checks and understanding of because camera is just an eye to understand what exactly happens on the production line. We create we added Tensor Core equipped computing edge units and developed our own computer vision models and trained a neural network to detect the exact defects that we expect to see and how a good products will be at the output. So we will be able to detect issues or defects in the product as soon as it appears on the production line and immediately alert production worker. We also integrated this system with a plant SCADA network, so it was automatically slowing down the production line, giving operator time to go right at the needed place and fix it ahead of future uh, of moving this product in the next stages of production and basically wasting money on creating already defective product. Um, So yeah, once we implemented it in one line for one product, it was decided that we saw that it yielded in good results, and we decided to scale it. As a result of scaling this solution, we built a whole alert and monitoring system that were collecting data, historical data, doing some predictions and correcting the production processes, and also it covered not only just building materials, but we also, for those who are interested in the uh, alternative energy sources, we also covered the quality control on the solar panels production. So as a result, you can see on the screen right now, we got average plant worker reaction time from 15 minutes to 30 seconds. So basically from detecting a defect on the ready product to detecting a defect in the early stages of its appearing. In general, across all of the plants and all of the production facilities, we got almost 800K in the money savings. It is included returns, scrap utilization, at a lot of uh, defect production related issues. And we gained 100% real-time visibility across all plants. So all the workers in plants on the plant on the site can see what's happening right now on their production line, and also big managers can also see what's happening across all of the plants at the same time. So that's
So
all.
I don't know if you knew, but I was visiting one of the plants by myself. It was in San Jose, California, and the solar system in use. And visibility is really resolves a lot of the problems at this factory. So yeah. Do you want to add about the solar, how we adopted this for the solar production, solar panels?
Well, we basically scaled our system across all of the plants and production facilities. We had a little bit different approaches on how to detect defects in the solar panels, but that's very production specific information that I'm not able to disclose here. But we have solutions, and we know how to work with different materials, and we have experience, and based upon your product, your production facilities, and what hardware you have on site, we can build solution just for you.
Perfect. Move to the next case.
Yes.
All right.
Okay, so now let's move on to the IoT environmental monitoring. That was a different case, but also for a big US manufacturer. And the problem on their side were that their products were super sensitive to temperature, humidity, both during manufacturing and storage, and raw materials preparal, etc. And they already had the processes running. They already were measuring a lot of those data points and gathering this information, but it anyways yielded in quite big amount of defectively produced materials that they weren't able to find the root cause of it, because it seemed on the paper, on those graphs, that everything is perfect, but somehow the batches were different. Some batches good, some batches not. So what we done, first of all, we integrated with their on-site system. We labeled all of the existing data points. We understood that there is not enough of them, and built small hardware solution that were gathering a lot more of environmental data, like on the plant and also outside the plant. Uh, with all this the big data pool, we asked our data scientists to build pipelines and to analyze this data. So as a result, we found out that even though our environment inside the plant were highly controlled, it it was still dependent on the outside weather. So we were able to proactively uh, monitor weather conditions and add corrections to the process of production on the fly to make sure that the end result conditions were always perfect for this particular products. Um, it is not the uh, full-blown AI cases like we usually see them, but AI also as data pipelines and data and all of this big data analysis and predictive algorithms. It's all part of the data science. So everything here were handled basically by the data science department in terms of data analysis, as well as computer vision models from the previous case. So as a result of these implementations, you can also see numbers on the screen right now. We got 18% reduction in product defects, 11% production inefficiency improvement, even though 11% sounds like the smaller number here. Actually, in the clear money wise, it was the most the bigger win out of all this. And we reduce the amount of human intervention in the production process because the environment by itself were quite rough and that's not really healthy to go on site too often. So yeah, I think that's all that I wanted to
Yeah.
share on this particular case, and we can move on
Thanks.
to the next
Thanks,
one.
Andrew. Yeah, it's crazy how outside temperature can influence your like production chain because you think about your production facilities in that kind of the close environment, but it's not. It's very well connected. And I just spoke with um, second biggest manufacturer of the airplanes in the world. You can guess who this is. And they also was thinking about so how the outside temperature influence the production, the facilities, and how to measure this during the whole year across. So yeah, let's move to the third one.
Okay then. Uh, so let's look at the third and the last one for today. So there we did this project was for the comparably small roadwork maintenance and repair contractor. Uh, we were looking to automate as much as possible of the road maintenance processes for this contractor because they have a lot of highly skilled technology teams. They have actual robots on their side, but not much of workers, and it was hard to find the operators for these quite complex robots. So first of all, we started with regular maintenance is to implement uh, computer vision road quality analysis from the drones. It was just Mavics or it was basically usual drones that you know and familiar in your life and so many times. But then footages from these drones were analyzed through computer vision to detect defects of the road surface, like potholes, some road markings, defects, and all the spectrum that possibly can happen inside the city. Uh, then automated data pipelines were planning repair works, ordering proper materials, planning human resources, and all of the scope. And the next part, the last one, but the most interesting on my own opinion, that took the most of the work from us, is additional software for this roadworks robot. The hardware were already present. but we wrote a fully new software also with computer vision and with a lot of various automation and defect detection things additionally added to it, including even some sensors, extra sensors, I mean. So it was basically a robot that performed road maintenance by itself without control from human. He was filling the potholes, he was adding the road markings, he was doing a post-job inspection, and after that, he was automatically calling the call center to ask to pick him up because he already finished the job. And then one last pass by drone to make a final analysis and confirm that everything is fixed. So yeah, it's a rather short description, but it was quite big and interesting project, but mostly in technical terms.
Thanks, Andrew.
And yeah, and regarding the savings and optimizations, you can also see numbers right on your screen.
Yeah, that's the great project of automatization actually, because everything that can be automated was automated here. The road inspections from the drone with computer vision model, we can estimate from the drones. We created the algorithm to detect all the cracks, all the potholes in the road. You see at the screen that after that we could convert this to actually the amount of materials plus labor cost plus the cost of machinery plus the cost of renting the equipment, and actually it can run the very clear estimate. So how much in dollar amount, in material amount, we need to replace to fix this part of the road. And this was really amazing. So right now we can run the clear numbers and estimate the amount of materials properly, the amount of working hours properly, and those estimates were actually very accurate. And of course, we are we are continuing this work to make them even more accurate. The computer vision model, it's trained on the newest data. It's always improve itself. All the processes also improve themselves. And I'm sure you will see the results of that at the US road. Maybe you already see them very soon. Okay, thanks, Andrew. Thanks for presentation of our cases. We can move further for our presentation today. And right now we'll talk about why automation projects fails sometimes. And during our work with our customers, with our partners, we highlighted three main problems. And let's start with the first one: integration complexity. Nobody mapped upfront. You have the data, your ESP, you have SCADA, MES in different system, and sometimes integration of those may take 3 times longer, even more than you expect for, because you have legacy, because all the data need to be connected with each other. You need one data lake, and you need to map this overhead upfront if it's not yet ready. The second one, success metrics. Sometimes even our clients who run the huge productions, they don't have success metrics in place, and they operate. We are interviewing our customers, we visiting the facilities, and we want to help. And we ask what will be the metric that how you will say that our project is successful. What will be the success metrics? And sometimes we hear that we will reduce downtime. We will make this operation faster. We will reduce defects. And this is the time when you need to go deeper. Okay, reduce defects. For how many defects are we having right now? And what's the amount of defects you would like to get at the end of our projects? What will be the measurable amount of them? Or one of our recent cases, we were invited to warehouse facilities in Germany, and our client, he wanted to automate to create his warehouse human-free, with the robotics, with the ERP, and without human labor. And he said, I want to run this project to remove human from the chain and make the processes faster. But the starting point was that we didn't know what's the one operation, how much time it takes. So we cannot measure success if we don't know the base metrics. So usually we start with measuring the base metrics and then see whether it's possible or not to achieve 2 times faster, 3 times less defects, or one, as here's an example, 180K per year scrap in line 4, as an example. Those are the metrics. And the third one that exists but isn't ready to use. This is something that Andrew talked about one of our projects today into IoT sensor platform. We have a lot of data in our ERP system. We have a lot of sensors, IoT devices. We have all this data, but sometimes we're still making very blind decisions based on God's feeling, based on like 2 years ago report that we have. And this is not the problem of the data. This is the problem of visibility. And of course, AI excels only where we have the clear data. And we need to start to prepare this. We need to start with reviewing everything that you have before we move with any other scoping or automation implementation. Yeah. 3 questions to assess your own operation. So this is like some kind of the homework, and 3 questions we also asking our customers before we start. You need to review your process, your manufacturing process, and see which in your production, which point in your production chain costs you the biggest amount of money. Is this downtime delay? If this is amount of wasted material? Is this amount of overhead hours of your workers? And you need to estimate the biggest pain points, better in the dollar amount and better for the 1 year ahead. And this actually may be the budget for your automation project, because if you will reduce this time, spending much more less for the custom software that may resolve that, you will receive the biggest return of your investments at the end. And of course, this will make company more profitable and you more successful manager. Where do off-shelf tools fail from your team still fills the gap manually? So from our experience, the off-the-shelf tools, actually the software that's already in production, is solving about 70 to 80% of all the automation. You still have, even at the big production facilities, you still have 20-30% of manual work that actually your personnel need to do manually just to connect like one system with another. This 30%, it's exactly the same point when we can step in and resolve those problems with the custom software that will be tailored to your machines that may be quite outdated already, that will be tailored to your business processes, to qualification of your workers. So there is not like magic button here. Custom software resolves custom problems, and we are in Techstack exactly at the same spot when we can tackle those issues. And the third one, it's where you already talked about this a bit. It's where you have data, but you still make decisions on blind. Our data analytics can take much more information about that, but this is about the data labeling, this is about data organization. Usually working with our customers, it's not always the case that we can already use existing data. Sometimes we need to spend time to preparing that, and only then based on this, making data-driven decision that will bring success for you. Yeah, we will talking about the projects when we can help, where the Techstack can plug in to solve business needs. We already talked about quality control and defect detection system. Actually, this is everything connected with the computer vision. We have a great computer vision division here in Techstack, and if you're struggling to maintain the controls, to maintain the quality of your production, the quality control system may be the great problem solving for that. We worked on predictive maintenance. This is the sensor kit that may help to run your machines and predict the exact maintenance of the life of these machines. It's IoT sensor monitoring. It's also the production field operation. Five, it's energy and data platforms. We haven't talked about a lot about renewable or energy projects today, but we have a huge experience here in Techstack. Maybe we'll have another webinar dedicated to renewable energy projects. And factory automation and process control. We also talked about this a bit today in one of our cases. All right, so okay, so it's time for the questions. We still have enough time to answer your questions. Yeah. So
So
let me open that.
I seen the
Andrew,
question.
you like something?
Yeah, there is there is
Pick the
couple
one.
of them in the
G-
chat and one in Q&A section. So let's
Oh,
start with
cool.
Q&A from Alex. So what are your percentages and deal sizes in greenfield and brownfield in Europe and USA? Well, Alex, it's part of this information could not disclose due to like business limitation. I hope you understand that. But we're doing mostly in greenfield. That is, it depends on what you actually can thinking about brownfield because if customer already have some system at place on the site and we're doing some model or some extra for this system and integration with already existing system, someone will consider it brownfield, but for like how I see it, if we are not replacing any system but doing another layer, it's a greenfield. So yeah, like on 80 to 85%, I would say like that, it's a greenfield.
Yeah. Cool. So, John, what's the minimum budget to start AI integration? I think I can answer, Andrew. Maybe you will add. So, of course, it's like this question may need to be more specific because, of course, each project depends, and it depends from the nature of the project. It depends from the machines that you already have in place. Few cases. So right now we are working on computer vision model for the road construction work from Australia, and I think this is the smallest project that we have right now. We can deliver the computer vision model for also the road construction company for 50K in 3 months. So actually, we will already go into develop the computer vision model in the first months that will have about 85% of accuracy, and the next 2 months we want to increase it up to 92%, which is the baseline. This is the customer requirements for that. So of course, this is like very small project. Some of the projects that we showed today, they have bigger budgets and took 6+ months to develop. So it depends from 50K to multi-million projects, of course. But as I said, it depends from the project nature and from the scale. Andrew, I have a question to you. How long does it take to see actual results after you start? Like from kickoff to something working on the line? That's actually a good question.
Well,
Again, not specific, but still.
well, it is really it really depends a lot because as Maxim just mentioned it, we shipped for one of the rather smaller projects. We shipped first working models that are already yielding some measurable results just in under 2 months or over 2 months, something like that. Maxim, please correct me. But for for some of the projects that I presented just a couple minutes ago, there was much longer times because it needed a plant visit, integration with existing systems that are in the plant with their SCADA system, sometimes even an MES system, creating full-blown digital twins, and developing hardware, which also takes time because it's not just off-the-shelf sensors. Yeah, for the plants. We need to create a really robust hardware. We need to test it in special test chambers to make sure that it won't fail in extreme temperatures, in extreme chemical condition and other production specific environments. And then make sure that it will work stable and long enough time to yield good results without even without maintenance, because if it's harsh environment, then maintenance is also cost a lot. So
Makes
yeah,
sense.
for some of those projects, from the beginning to the final implementation, I mean, including scaling and finishing and shipping and just moving to a support stage, it took like 2.5 years, something like that. So yeah, so times really varies between the project size and effort required.
Yeah. Yeah, and of course, here is the planning is the key in this kind of long-term project. So if you knows your KPI, if you knows your end goals, and you're signing off for like multi-years projects, you need to bring this to your board, right? That's the huge investment, but the amount of the dollar amount of savings can be much can have a greater return. And we can, at the discovery phase, we can plan this, we can create the great deck that will capture the end results and all the milestones, how we will deliver this project and where you will receive the biggest return of investment. And this is what we are helping with our clients at the planning stage. All right, let's move to the next one. Okay, if a company has equipment that's 15, 12 years old and is it still possible to add IoT sensor to it? Does it typically require newer machines, or is it required? That's the great question. Andrew?
Yeah, good question. We it's generally it's not. We can work with almost everything. It just depend. It just will require, in some cases, more effort or more integration, hardware bridges or different solutions to adopt those machines. In our practice, we had one machine that was fully manually operated. It has analog gauges, it has analog operator inputs. So basically, it was this levers and rotating dials, and we were able to integrate it to our system to build a hardware and software bridge to work with this machine. Was mostly for monitoring because uh, uh, still controlling of this machine is a bigger task, and we also limited here by solutions that we can use and that manufacturer of this machine allows to modify to maintain guarantee and maintain. But for the monitoring of this machine, there is no limitations.
Yeah, and maybe I will add from my side that it's most common case when we are dealing with quite old machinery, quite old equipment, which is like 12, 20 even 20 years old. And That's the normal case because the equipment, the machinery cost a lot. It's depreciate over the time, and you cannot run the very successful businesses. You will update your equipment every year because it's a huge investment. So we have experience with old machines. Of course, we have experience working with the newest as well. Yeah, maybe one more question. To check your references, volume, and the size of the project you deal with. Yeah, we already partially answered on that. It can be something rather small with, let's say, 5 people development team. And maybe this is the question to walk you through how we are working here in Techstack. So first stage, we are reviewing the requirements. Actually, we have audit with the clients on their facilities. We're talking about the goals our clients want to achieve. Then we creating our proposal. Actually, how we will resolve this problem, technology languages, the team size, the timeline to delivery. And after that, we initiating the planning phase or discovery phase. And at this phase, we can accurately estimate the volume and the size of the project at the long run. So it can be something rather small, but it can be like, well, multi-years project long with multi-million amount of dollars. So we are working at the very huge scale in this regard. And of course, planning is like the most important phase in every project. And usually we're spending this to estimate everything properly, not only the dollar amount, but also the timeline. And we can run the project with 1, 2, 3 developers to the biggest project that we are having right now, it's 60 engineers just working for the one project. So sometimes it can be something very huge. Andrew, I think that's it for today for the question. Do you want to add something from your side?
Well, maybe a little bit. We prepare it and I showcase it like just a limited amount of projects that we implemented. But please keep in mind that we also implemented a lot of things for a lot of projects for the renewable energy and small energy production and distribution facilities, and even a little bit of the manufacturing, the manufacturing tools distribution also. So yeah, we have quite a much broader experience that I showcased today. So if you're interested in something and if you have any issue or you think that you might have any issue on your plant and your production, please feel free to reach out and we will look at your particular case and we'll try to find a solution that will fit you best.
Perfect. Thanks, Andrew. So yeah, we are just about in time for today's. Of course, this QR code, you can book a call with us through this QR code. Here in Techstack, me or my colleagues, Andrew or Andrew's colleagues, will be happy to spend some time discussing your particular case and as I mentioned before, of how we work to gather enough information, creating proposals, run through several discovery meetings. This is how we work. And the record of this webinar will be sent to you within 24 hours. If it was useful for today's, we'll be very happy. We will be very happy for your feedback. As Andrew mentioned, we have a lot of other projects in other domains. Maybe this will be the topic of another webinar from us. But we'll be happy for your feedback and we'll be happy to work on your case to put some our R&D efforts to create at least the proposal for you. From our experience, we receive very good result from the conversion of our proposals to actual projects because we make them very detailed, we make them with the slide deck, we make them with the real data. And this is our investment into future collaboration when we already spent our time making a due diligence on site or maybe remote, and putting everything together for your board to take the decision whether or not to proceed with this project. So thank you guys, and it was a great pleasure talking with you today. Andrew, thanks for insights, and yeah, have a great day.
Have a good day.
Bye all.